Hello, everyone. My name is Michael Irwin. I'm part of the developer relations team here at Docker. I'm super excited to be here to welcome you to the next webinar in our series that's supporting the AI machine learning hackathon. And I'm super excited to have OctoML here today, and I'll pass the baton off to him in just a second. But before we do that, just want to remind everybody if you're new to this series here, and if you want to join the hackathon, we'll put a link to chat here in just a moment. This recording, as well as others in our series, are available on DevPost, who we're partnering with for the hackathon. So feel free to go over there, view all the different resources, check out all the different workshops. There's lots of different resources to help you get started with your hackathon. And if you're still thinking of ideas that you want, or that if you need ideas to help you get started, there's lots of great ideas there as well too. There's also a Docker community Slack channel that is a great place to look for teammates or bounce ideas off each other, and also just get help as well too. So with that, I'm super excited to have Basim here with me, and he's he's one of the experts here. So I'm looking forward to learning from him as well, as we learn how to set up Llama 2 endpoints for our LLM apps. And so with that, I'll pass the baton off to you and let you introduce yourself and go from there. Thanks for joining us today.
Sure. Thanks, Michael. Hi, everyone. My name is Bassem Yacoub. I'm a solutions architect at OctoML. I've been in different professional services organizations and solution architectural organizations for the past 20 years, notably at Microsoft Professional Services and AWS Professional Services. And lastly, now my current position is solutions architect at OctoML. I come from an application development background, and I've been focused on machine learning solutions for the last 5 years or so. And for the past year, like a lot of you probably, it's been mostly focused on generative AI. So I'm very excited to talk to you today about OctoML and our OctoAI compute service, and specifically how we can use Llama2 endpoints, how you can quickly create them and use them in your ML apps, uh, and start building very quickly by using the OctoAI service. So let me share my screen. Okay. So the agenda today, as I was saying, we're going to introduce briefly OctoML and our OctoAI compute service, and then look at the Llama 2 endpoint, talk a little bit about RAG or RAG framework, and then I have a bunch of demos for you, starting from a simple demo that is just a chat with an LLM model, and then we'll see how we can do a question answer on a PDF document. And lastly, we're going to be querying two models simultaneously using context info that's been ingested from the web. Um, before we do the demos, I'm going to walk you through like how you can create an account on the OctoAI compute service, and how to access a Llama endpoint and clone it to your account if you want. Um, I'd recommend that you follow along with me because we will be using this endpoint or endpoint URL that you get in the demos later on. Okay, so a little bit about OctoML. So we were founded in Seattle in 2019. We have about 100 employees across the globe. Um, our co-founders were, or still are, part of the Apache TVM open source project. For those who haven't heard of it, it is a machine learning compiler, specifically written to optimize machine learning models and target specific hardware platforms, and change or enhance the intermediate layers generated during the machine learning model compilation process to be optimized to these targeted hardware platforms. So what's our mission at OctoML is to provide easy access to efficient compute. So I'm sure you're all aware that the generative AI workloads, they require huge compute power. So it's, hundreds of gigaflops for generating a single token, sometimes several teraflops for generating an image. So as the world continues to adopt and grow the use of Gen AI, we think that we should have like more efficient ways to do inference for Gen AI models. So we want to help democratize Gen AI by reducing its footprint. When you log into the OctoAI.cloud website, you will, and we'll do that together in a second, but you will be able to see a number of templates, quick start templates that we have, or example models that we have. So these include like a lot of the foundational models, open source models, like Stable Diffusion, SDXL, Whisper, Llama2, Segment Anything, and several other models. So you have the option to use these out-of-the-box endpoints right away from our cloud, or you can also upload your own model and get an endpoint of your model hosted in our cloud and start using it. The other capabilities that this compute service provides is not just running your models in the cloud, but we also do auto scaling for you. So, as your demand and users grow, the service will scale automatically to support your needs. We also do the model optimization for you, like as we talked before. So these templates that are available on our site, they're all models that have been already optimized, and so they run faster than the vanilla equivalent. So, for example, our Stable Diffusion is the fastest in the world as far as we know. We can generate SDXL images in under 3 seconds for 1024 by 24 by 1024 size. And our Llama2 benchmarks are very fast as well. I'm going to show you some of that. The last capability is tuning. So we have existing fine-tuning capability now for Stable Diffusion, and we are working on fine-tuning for LLMs and Llama2 that's going to be released in the near future. Some of the customers that are using us right now, they're building very exciting applications with generative AI. We have customers using image generation for fashion design. We have customers using LLMs for improving writing and emails, basically as an assistant. And we have customers using both image generation and text generation in single use cases, like generating bedtime stories for children or research papers. So as a developer, the ML lifecycle usually looks something like this. You need to be able to choose the right model for the job. You need to tune the model for your use case, integrate the model with your application, make sure it's running fast enough, push it to prod, scale it up on prod, monitor it, look at the costs, and so on. So By using a platform like OctoAI, this is all done automatically for you. And this, again, we run the model, we do the scaling for you, and we allow you to tune the model for some models as of now, and hopefully for all the models in the future. And this is exactly what our customer is saying. So Justin Mayer, the CEO of Civet AI, their biggest challenge was to find easy and efficient ways to build their applications as they continue to grow very rapidly, and they don't want to worry about all those 6 or 7 steps in the ML lifecycle. So finding a service like OctoAI and using it for their stable diffusion image generation, really made it a lot easier for them to grow quickly. So with that, I hope you have a better idea about what is OctoML and what is the OctoAI compute service. And let's jump right into the portal. And if you haven't done so, you can create an account and look at the existing demo models or example models. So if you go to octoai.cloud, make sure you can see my screen. So the URL is octoai.cloud. You should get to a landing page like this, and there should be a login pop up on the screen if it's your first time. You can sign in with your Gmail account or with your GitHub account. So it's a fairly straightforward process. And as soon as you sign in, you should be able to see something like this. The example models are the templates that I was talking about. So if we look here, we have several example models. On page 2 is going to be the ones we're interested in today. The Llama2 13B, the Llama2 7TB, and the Llama2 7B. Okay. If you click on any of the models in the demo tab, it will give you an endpoint URL, and it will give you a demo curl command that you can use to query the endpoint. So the other thing you need here, as you can see, is a token. And so you can click on generate an API token and give it a description and click generate. Okay, so that will generate your API token. So you would copy that and keep it in a text file. We'll be using it in the demo together with the endpoint URL. Okay. All right. So before I jump to the demos, I want to cover 2 more slides. So a little bit of background on Llama2. So OpenAI and ChatGPT and the launch of ChatGPT last November, it was definitely like the iPhone opportunity for generative AI. It's what started this or gave this movement like a lot of steam, and everybody started becoming aware of it and building apps around it. And then Meta started building the Llama models as somehow open source models, and the lessons continue to get less strict in Llama 2. Obviously, we we're all for open source, and we think it's much better for developers, much better for the community, and accelerates the innovation. As you saw, we have 7B, 13B, and 17B models available on our platform right now. The available templates are quantized, and 7B and 13B, they can run on 8NGs, and 70B, it's running on A100. And I'll show you, how you can clone it and look at the pricing information in a second. Before we do that, just wanted to show you the benchmarks. So as you can see here, our Llama models, anywhere from like 30% to 100% performance improvement on the tokens per second, as compared to the vanilla, baseline Hugging Face open source models. Okay, so moving on from Llama2 to retrieval augmented generation. So what is RAG, or retrieval augmented generation? It's basically an AI framework that exposes external knowledge to your LLM. One of the main challenges is that the LLMs take incredibly long time to train. So usually there's a cutoff date for training that is, several weeks to several months. And usually there is also specific domain information that the model did not have access to during training. And so with RAG, you are basically augmenting the knowledge that the LLM has access to in order to answer your question. On a conceptual level, you can think of it as two components or two steps. You have a retriever that does some kind of search and retrieves relevant information from your specific knowledge base, and the generator, which is your LLM that uses this knowledge base plus the question that you asked, or the query, to generate certain output. So a very good analogy is the detective and storyteller. So the retriever is the detective that collects the clues and the evidence when it gets the question, and the storyteller is the one that weaves this and provides a solution or an answer as an output. So at a conceptual level, this is what RAG is. And more logical components. So we usually start with the knowledge or your documents, and then there is a component that chunks this into chunked pieces of text. There is an embeddings model that takes these pieces of text and generates the embeddings. The embeddings are basically numerical vector representation of these words or tokens. These embeddings are then stored in a vector database, and there are several ways of several options of doing vector databases right now. Some of them are inside Python packages and can be hosted locally, and some of them you can deploy to Docker containers and spread them into multiple nodes and multiple pods, and some of them you can use them as a SaaS service in the cloud directly. But whatever option you use, at the end of the day, it's a database that stores these vector embeddings, and they usually come with very fast and very efficient vector search capabilities or vector search algorithms that allow your RAG application to query those embeddings and get the relevant information, and then pass it alongside the prompt to the LLM, which then generates the final result from this context information that it got plus the user prompt. So hopefully that makes sense. Any questions so far, Michael? Seems
Mine
like.
helps if I unmute myself there. Nothing's coming through yet, but this is probably a good chance to put a reminder as well too that if anybody's got questions, feel free to drop them in chat, and we'll be able to answer them along the way as well too. So I guess keep up the good work then.
Thank you. Okay, so let's switch to the demos. Okay, so if you're on the one of the Llama2 endpoint pages and you click on deploy endpoint, so based on the model that you selected, it will give you the choice. So for 7B or 13B, it can only be deployed on the A10G, which is a medium size in our pricing. And if it's the 7TB, then you will only see the large model. And you get very transparent pricing, how much you're going to be paying per hour, per second. And we're also planning to release per token pricing. That will be coming along, in the next few weeks or months. You can also specify the minimum number of replicas or the minimum numbers of instances that you want to have running. So if you leave it the default, then after 5 minutes of the endpoint not getting any requests, it will go to 0. So you won't be paying anything. You can obviously change this number to be smaller or larger, depending on how much you want to be charged for idle time, versus how much you are willing to wait for cold start when you issue a new request. You can also have the endpoint publicly accessible, which of course is not something we'd recommend, but if you choose to do that, then the requester does not need to send that API token that we saw earlier. And then once you hit deploy, then this will create an endpoint in your account, and it will give it okay, sorry, this is because I have something with the same name. So. Okay, so now I have this endpoint cloned in my account with minimum replicas 0, maximum of 3, and it has a different URL than the demo endpoint, and I'm going to need to pass my API token in the curl message here to get this to work. So let's start with the first demo. One thing I would like to point out here is that we have our LangChain providers. So I'm sure you have heard of LangChain if you have been working with LLMs, in the last several months. So we have our own LangChain provider under LangChain LLMs Octo endpoint. And that makes it even easier for you as a developer to write your code to use your OctoAI endpoints through LangChain. And you get all the benefits of LangChain, like being able to create chain prompts, being able to use their Chroma Vector DB, do vector searches, inline without having to write any code. So yeah, so basically you can use our LLM object in LangChain, and there are a couple of examples here. The one that we'll be using is the one that corresponds to Llama2. So all you need is the endpoint URL that you got from creating the endpoint on OctoAI, and your API token that you can store as an environment variable, or store it in an env file, like I'm going to show you in a second. Okay, the other provider that we have in LangChain is the embeddings provider. So as I mentioned, when we do the RAG scenarios, we need an embedding model that will ingest the data source and store the tokens as numerical vectors. And there are several embeddings models that you can use. There's one from OpenAI, and there are some open source models, and we actually provide the instructor large embeddings model as well. So you can see it here in our example endpoints. So you can create another endpoint based on the instructor large model, and this can be your embeddings model. So you would have both your LLM model as Llama2 and your embeddings model as instructor large, both of them running on OctoAI, both of them open source. Okay, so these are the LangChain components that we have currently in the package. So as soon as you do, pip install LangChain, you're going to have this automatically available to you. So let me switch now to my Visual Studio, and let's clear this. So the first demo that I wanted to show, it's very simple chat application. So this is command line chat application. All the code is available in a public GitHub repo that I'm going to paste in the chat in a second.
So just a quick note, it looks like you're just sharing your Chrome window. So if you're on VS Code, you'll have to swap over there.
Thank you.
No problem.
Okay, you can see my VS Code now, right?
Yep, good to go now.
Okay, great. Okay, let me paste the GitHub URL also for you in the chat here. We're doing this. Okay, so yeah, this repo has 3 main Python scripts. So the first one here is for the simple QA, and the main code that you need to write is getting the endpoint URL from your environment variable or from an env file, and then passing the Llama2 model name. So if you use 7b, you'll type 7b, and 13b you'll type 13b, and so on. And then you can pass the additional parameters for streaming, maximum new tokens, and there are a bunch of other parameters that you can see in the docs. And then here we're just using the LangChain prompt template. So let's run this real quick here. So okay, I removed my API token, so let me just paste that in the environment file, and it is really long, so you won't be able to it. Okay, so try this again. Okay. So it's going to initialize the model now, and I have a sample question, who is Leonardo da Vinci. So it used that question in the LangChain template prompt, and then it executed the LLM chain.run, and this is the answer. So he was an Italian polymath, an artist, and inventor. Okay, and then you can obviously continue the chat and ask more questions. So this is simple Q&A. It's not doing any RAG. It's not connected to any additional data sources. Okay, this is just to check that your endpoint is working, and you can use it with LangChain. The calls are going all the way through. Okay, so now the next example, we're actually going to do RAG on a PDF file. So this is the PDF file. This is it's an open source Sherlock Holmes story called The Adventure of the Speckled Band by Arthur Conan Doyle. So I'll have that file in the GitHub repo as well. So the code here is going to basically open that PDF file using the PDF reader component in the Llama index. And then it's going to instantiate the LLM model. Again, I'm using Llama2 7B here. And the task is to write a response to the question. And I'm using the instructor large endpoint for my embeddings. So this is my embeddings model. And I'm creating an object of OctoAI embeddings class and passing it our instructor large embeddings model. So this is going to do embeddings for the PDF file, and then store it in the GPT vector index for Llama index. And then after that, I can ask questions about the PDF document. So let's run this code. Okay, so this is going to take a couple of seconds because it is reading the PDF file and then calling the embeddings model to generate the embeddings for the entire PDF. But it's done now, and so I can ask it questions about the document. So let's say, who is the author of the book? So it's saying, based on the provided context, it's Arthur Conan Doyle. Let's say, who is the main character? So the main character is Sherlock Holmes. And let's ask it one more question. What is the story about? Okay. So it's describing a mysterious and frightening event because it's basically a murder mystery. Okay, so this is how we can do QA on a PDF file or multiple PDF files. Again, I hope that you got the link to the GitHub repo, and you can follow along, either now or later. But the main idea here is, all you need to supply is your embeddings model and your LLM model URL here. Okay. Okay, if we don't have any questions, so I'm going to move on to my third and last demo, and that that demo allows us to make two simultaneous requests at the same time. So we'll be creating an instance of the 13B endpoint and the 7B endpoint, And I'm using multi-threading to send the two requests simultaneously. And we're going to get responses from both models. We will see the difference in the quality of the response, and we'll see the response time as well that it takes for each model. The other difference here is that this is going to be retrieving data from web content. So I have two data sources. Here I have the OctoAI docs and the Kubernetes docs. So I basically ran a quick web scalper here, and I was able to read the content of the documentation for OctoAI and Kubernetes, and stored that in ChromaDB. So the embedding piece has already been done because this takes a little bit longer than what we did for the PDF. I didn't want to do that during the demo, but the code for doing it is here. So we are using the vector store. The vector store that we're using here is the LangChain ChromaDB. So this call here, basically stores the pages into your vector store. If it doesn't find the ChromaDB data sources. Okay. So let's run that. Well, we can start by asking a Kubernetes question. So it's going to be okay, that's interesting. Okay, so it's interesting that it's saying it didn't find the transformers package, but I'm going to try that one more time here. Okay. Okay, I think there might be an issue with the Llama 13b endpoint, but the 7b seems to be working. Okay, maybe it's the opposite actually. So the 13b is working and the 7b is not working. But regardless, so we saw the 7b earlier. This is the 13b. So I'm asking it what is the Kubernetes control plane, and it's looking at the documentation that has been stored in the ChromaDB, and giving me the answer based on this additional context. Let's try asking another question, and this time I'm going to change the data source to the OctoAI documentation, and I'm going to ask it, how to avoid cold starts. Okay, so now I'm getting a response about how to avoid cold starts, And you can see it is referencing, the OctoAI in the answer. So it's clear that, it is reading the data from the OctoAI docs that are stored in the vector database and then generating the answer. So that's the third demo I had, and the code is also in the repo there. One last thing I wanted to show here is if you want to deploy this, for more of a production scenario, one of the options I like is the Lambda function on AWS with the container image option. That was added to Lambda about 2 years ago, I believe, and it increases the size limit that you have for a Lambda function from 250 megabytes to 10 gigabytes. And the great thing about that is, if you want to package all this code and host it in a Docker container, it's going to be around 3 gigabytes because you have the ChromaDB, you have LangChain packages, transformer packages, and all these packages are pretty large. So you're definitely not going to be in the 250 megabytes. You can, obviously put it in ECS or on your own EC2 instance. But I like the Lambda function because it's, fairly low maintenance. It's very cheap, and you can just, slap an API gateway in front of it and, give your front-end developers the URL to call. So one of the great things about using Docker and the AWS serverless SAM CLI is, you can get all this packaging done automatically for you. So here, I just had to write this Docker file, and basically I'm specifying that I want the image to be the AWS Lambda Python 3.11 image. I'm adding my environment variables. Then I'm copying the code files, and then specifying that my Lambda handler is called main.handler, which is this function here. So this is the entry point to the Lambda function in my code. And then you basically need to install your AWS SAM CLIs, which you can do with pip here. So pip install AWS SAM CLI, and that will install your the SAM CLI. You'll the first time you run it, you'll have to log into your AWS account and provide a secret. But then after that, all you have to do is do SAM build, and this. Sorry, I'm in the wrong folder. Okay, so this will use that Docker file that I created and generate the Docker image locally, and then I can test it on my local machine by doing SAM local invoke. Actually, let me just show you the Docker image first. So here, the image was created 22 seconds ago. It's called the ask Llama function. These settings are coming from that template file. And I mean, these template files, the definitions are pretty easy to create, and there are several examples on the AWS tutorials and repos. But basically, I'm telling it to create a Lambda function and use the main.handler here, and use my Docker file. So by running sam.build, it created a Docker file from the AWS Lambda Python base image. And then I can test it locally. So sam local invoke. This will make sure that the code on my container, code is running from my container, basically. Okay. Okay, so now I'm getting the response. And oh wow, the two endpoints are working now. So this is the first response from the Llama 13B, and this is the second response from the Llama 7B. Okay, so these responses are coming from the code that is running in the container on my local machine. Now, if you want to deploy this to the cloud, Sam will basically get your Docker image, send it to AWS Container Registry, and then you will be able to create a Lambda function from that image that has been uploaded to your ECR. You do that by just typing sam build. So, sorry, it's sam deploy to deploy to AWS, and we can choose the guided option. So it's going to ask for your CloudFormation stack name, region, a bunch of other questions, and then okay, and now it's going to actually start the upload process. Like I said, this is like a 3 gig image, so it's going to take a while. So I already have it in my AWS ECR. So let's see. Okay, so after we run sam deploy, if you go to your ECR, you should find something like this, ask llama function. So that's the container image. And then you can go to Lambda, click on create a new function, create a function from container image, give it a name, and give it the URI of the container that we just uploaded. And then it will look something like that. So this is the Lambda function that I created earlier from the container image. And then you can test it in AWS. So my test here, I'm using the OctoAI docs, and I'm asking it how to create an endpoint, and I'm going to run this test. So now the container is executing in AWS Lambda, and should be able to see the response here soon. Okay, great. So this is the first response. In this version, I was doing GPT versus Llama. So the first response is from GPT, and the second response is from Llama. So now you have a Lambda function in AWS. Like I said, you can just create an API gateway and then an API key, and then start using it. right away with LangChain, ChromaDB, Llama Index, all this, working in the AWS cloud right now. All right, so that's the end of my demo. Any questions?
Good question. The chat's been really quiet today, but not much else has come in yet. But again, I'll put another reminder out for folks if they've got questions, feel free to ask them. And it's actually been kind of similar with a lot of the other sessions we've done. I think a lot of folks are still just absorbing and trying to figure out what questions should I have, and trying to figure out as well too. So definitely lots of good information that's been shared here as well too. So we'll give a couple seconds here to see if any others come up.
Yeah, no problem.
But I guess maybe one I'll just ask, and I know you
Sure.
touched a little bit on this earlier too, but like for example, looking at this list of models here, um,
Mhm.
it could be a little overwhelming. Of okay, I see 3 pages of models here, and like how do I choose where to start with for my applications? Obviously, some are probably going to be more tailored towards certain areas, but a lot of times when I see like MPT7B, like that's a pretty code name.
Right.
It's a code name there. So yeah, how can I know where to get started? What resources, what help can I have along the way there?
Yeah, no, that's a great question, and we're actually revamping like the whole UI, and it's going to be a lot more intuitive. So it's going to have sections for text generation, sections for image generation. So that's why I tried typing text in the search to see if this is available or not yet. But I think it hasn't been deployed yet. But yeah, in a couple of days it will be a lot easier to find the model based on your use case, whether you're trying to do text generation or audio transcription or audio generation or image generation. So the the correct models will be listed under the correct categories. For now, I think the easiest way would be to just use internet search
Mm-hmm.
and look or go on the Hugging Face hub and search for like the top leaderboard for text generation models or image generation models, and then come and try them here.
I'm sure there's a model that you can go and ask it about other models, and it'll.
Yeah, you can ask ChatGPT as
That's right.
well. We have no
Modelception.
problem with
So
that.
cool. And yeah, so okay, cool. Well, it's good to hear that there's additional resources and come out. I'll admit,
Right.
go watching through your demos and whatnot. It was neat to see all
Yeah.
the different ways that it can be applied. And I think about the PDF reading and analyzation and whatnot of the Sherlock Holmes story. Like, and that would have made going through schooling a lot easier. Just say, hey, read this book for me and help me out as well. So,
Absolutely.
uh,
Sorry, and the other resources that are available to you as well is our documentation. So we have documentation for most of the existing endpoints, as well as how to create your own endpoint using the CLI. Um, the CLI is available in both Python and TypeScript. We have some end-to-end tutorials, including uh, a couple of the demos that I just showed today.
mhm.
And the other resource is our Discord. So you can definitely join our Discord server, and you can ask any questions there. We have several members of our team and myself always monitoring these channels, so you'll usually get a response fairly quickly as well. So.
Fantastic.
Yeah, and the last, sorry, yeah, I might as well say that before there's also the intercom chat here on the website itself. So this is our customer success team. You can ask a message and start a conversation from here too.
Sure. Well, first off, thanks for all the demos, the walkthroughs, the resources, and everything else as well too. We do have one shout out from Trevor in chat. He said he joined late, but a great demo from what he saw, and he's going to watch it back later as well too. So again, hopefully it's be useful as well there. And again, as you just mentioned, that there's lots of different places we can go to get our questions answered and continue learning and understanding and building our apps and whatnot.
Absolutely.
So as I guess given a moment or two here with questions, still don't see much coming through or whatnot. But any final thoughts or closing remarks before we wrap up here?
I just want to say thank you so much for the opportunity, and thanks to Docker for all the great products and the great support that you provide for the developer community. I think the whole community wouldn't have been where it's at right now without Docker. And to the developers that are tuning in today, uh, OctoAI is here to help you build your AI applications quickly and easily. This is our differentiator here is that we try to abstract all the work that you need to do in model creation, training, inference, optimization, scaling, all that. You just get a HTTP endpoint and you start putting your code around it right away. So feel free to try it. Feel free if there is a model that we don't have right now, ping us on Discord or ping us on Intercom, and we are happy to work with you and work with any customer. And always looking for design partners and customers that would actually help us with their feedback and with building the product. So don't hesitate, and we would love to hear from you all.
Fantastic. Great closing remarks there as well too. And again, thank you for taking the time to share with us and helping educate us all a little bit more about how we can build our applications using these great new features and capabilities and tools. And it's great to see behind the scenes a little bit of how you and your company are just trying to make it easier for folks and lift the take the heavy lifting off from developer shoulders as well too. So again, thanks for sharing with us. So as just closing up here, again, this recording will be available as part of our YouTube playlist for the Docker AI Machine Learning Hackathon. Again, if you're just joining us, feel free to join the hackathon. It's not too late. Our next workshop will actually be having a mid hackathon check-in tomorrow. So feel free to come hang out and ask questions about the hackathon. We'll share other details and kind of future plans as well too. So feel free to drop in on that as well. And stay safe, stay well, and keep having fun with the hackathon. Thanks all.
Thank you so much.